The top view of a line capital AB, 80 mm long, measures 65 mm and the length of the front view is 50 mm. The NDA is in HP and 15 mm in front of VP and draw its projections. Now the NDA is in HP and 15 mm in front of VP. So this is the first condition we need to consider. The NDA, when you look from the front view, the NDA is in HP. So when it is projected onto the vertical plane, you will get small a dash. And 15 mm in front of VP. The 15 mm in front of VP is this distance. When you look from the top view, we can see that 15 mm in front of VP, which will be, when it is projected, it will be on HP. So the point will be small a. And a capital AB 80 mm long. So this is the true length of the line. The true length of the line will be 80 mm. Measure 65 mm in the top view. And the length of the front view is 50 mm. So that means when the top view line is parallel to, its corresponding front view will be in true length. In the sense that if I want to find out the true length in VP, so the top view line has to be parallel to VP. So that means when you look from the top view, we can see the distance with respect to VP. So the top view line is 65 mm long. So that means NDA is 15 mm in front of VP. So the top view of the other line, that is AB1, should also be in front of VP by 15 mm. But the length of AB1 has to be 65 mm. So first you draw a horizontal line parallel to VP at the distance of 15 mm in front of VP, and you measure 65 mm horizontally. So that is, the distance between AB1 should be equal to 65. So now the line is parallel to VP. So NDA is here. When this line is projected, we can see that the top view, which will be 65 mm, and when you project it vertically up, then you take the line of 80 mm long with A as center, cut an arc on this, so this vertical projector, so that it will go into cuts at this point, which will be capital B1. So this line AB1 will going to be the true length in VP. When you project this line directly onto VP, you are going to get this point B1 dash, because that is the front view of this capital B1. When it is projected, it will going to become the image, which is small b1 dash. So you will going to get a horizontal dash dot line, which will going to be the locus of B in the front view. So since this line is parallel to VP, so the line AB1 is parallel to VP, so we are getting the true length in VP. This is A dash and this is B1 dash. So this will be capital A and this will be capital B1. So this will be the, so now we got the locus of B in the front view. Now similarly we want to find out the locus of, we want to find out the top view true length. To find the top view true length, we have to make the front view line parallel, in the sense that the front view distance is 50 mm. So here in the front view, you take the distance of A dash B1 dash. A dash B2 dash is the line, which will be the length of this line will be equal to 50 mm. Why? Because if the front view is parallel, then its corresponding top view will going to be in true length. So that is the condition. So since A dash is on HP, so B2 dash should also be on HP. So length of this front view has to be 50 mm. So he has given the distance. The length of the front view is 50 mm. So from A dash you measure a distance of 50 mm and mark this point. Then draw a vertical projector in the top view. Then draw a vertical projector in the top view. So with A as center, because A is in front of VP, which we know, which is 15 mm in front of VP. So from this point, you cut an arc on this vertical end projector so that it will going to cut at this point, which will be marked as B2, small b2, because the length of the front view has to be the length of the top view here, which is the true length line. Since the true length line is both in the front view and as well as in the top view, it will be 80 mm. So by using the compass, you measure a distance of 80 mm and cut an arc on this end projector so that it will going to get this point small b2. So join a b2 with a true length line, which will be little bit thicker than the projector line. Once you get this B2 here, then draw a horizontal dash dot line, which will going to give the locus of B in the top view. Now we know the locus of B in the top view and as well as the locus of B in the front view. So now we need to find out the front view and the top view. So how to find out the top view and front view? Because due to the presence of the true length in HP, so that you are going to have the locus of B, which is at distance, some distance above HP, which we don't know, but which has been found out. Then with A dash's center, since the front view is on the endpoint of B2 is on HP, but actually the endpoint of B2 is not on HP. It is instead some distance above HP, such that the B2 dash will going to fall on the locus of B in the front view. So with A dash's center, take the radius of A dash B2 dash and then draw an arc which will going to cut the locus of B here. So this point will going to become B dash. Then mark this point as B dash and join A dash B dash with a dark line, which will going to show you that it is the front view. Similarly, we know the top view is in front of VP by 15 mm as shown here. But because due to the presence of the locus of B in the top view is at some distance from in front of VP, with A as center, you take the radius of AB1, which is the top view distance, which will be equal to 65. With A as center, rotate such that B1 will going to cut the locus of B here and then mark this point as B. Then join A and B with a dark line. So it will going to give the angle of inclination, which is beta, which is inclined to VP. So when you join B and B dash, both will going to lie on the same line. When you project the point from B here vertically up, and when you project B dash from the vertically here, both will going to intersect at this point. Then capital B will be the point which will going to be the actual line from A to B in space. So in other words, when you are going back, when you are rotating this A to, when you are rotating the B such that this B is rotated such that B is made in front of VP by 15 mm, so that AB1 will going to be parallel to VP, then we will going to project this, we will going to get the true length. So the path traced by this will be from here to here, which is made parallel, then we are going to get the true length here. Similarly, when you are rotating this A to B, from B it is rotated like this such that it will be made onto the locus of B here, so that A is on HP, so B2 is also in HP, so you are going to get the true length in HP. So this is how we can analyze in 3 dimension. Now we will going to solve the problem in 2 dimension, that is on the sketchbook. First we will going to draw the XY line and mark VP and HP as shown. The NDA is on HP, which is A dash, which is on XY line, and NDA is in front of VP by 15 mm. So from A dash you draw a vertical projector and measure 15 mm and draw a horizontal line. Then you mark this point as small a. And so now when the front view distance is made parallel, when the top view distance is made parallel, so that means when the top view distance of 65 mm, that is AB1, you mark first, we have this line from A, you measure the distance of 65 and mark this point and call this point as B1 and mark this point as B1. Draw a vertical projector to the front view wherein you will not have this locus there first. So since the top view line is parallel, so we can find the true length in VP. So the front view will be in true length. So measure the true length of this line, which will be 80 mm, by using the compass with keeping A dash center. Cut an arc on this vertical projector so that you will going to get this point here. So mark this point as B1 dash and draw a horizontal dash dot line here. So since the top view line is parallel, so its corresponding front view will be in true length. So mark this as capital A and capital B. So here, once you get this, so you write the locus of B. That means the front view of this point will going to lie on this. Similarly, I want to find out the top view true length. So to find out the top view true length, so we have to consider the front view. The front view distance is 50 mm. With A dash as center, measure the distance of A dash B2, which will be A dash B2 dash, which will going to be 50 mm. That is, NDA is in HP, and make that B2 dash is also on HP, such that that line is parallel to HP. So the front view line of 50 mm you made parallel to HP. So then correspondingly its top view will going to be in the true length. So then draw a vertical projector to the top view, and then we will not have the locus here first. So take the true length of the line, which is 80 mm, keep A as center, cut an arc on that vertical projector so that it will going to cut at this point. So mark this point as B2. Then join A and B2 with a little bit thicker than the projector line. So this will going to be the true length in HP, because that line is parallel to HP. Now we got the locus. Draw a dash dot line in the top view. So this, since the front view line is parallel to HP, so you will going to get the true length in HP. So you mark this as capital A and capital B. So this will going to be the locus of B, and write locus of B in the top view. And since this line is parallel, you make it bracket A and bracket B here, capital A and capital B. So now here the front view line is parallel because of the presence of locus of B in the front view is here. So B2 dash will be above HP by this distance without altering the length of the front view. With A dash as center, take the radius of B2 and draw an arc such that it will going to cut the locus of B here, and mark this point as B dash and join A dash B dash with a dark line, which will be the front view. Similarly, the locus of B is here. The B1 is in front of VP by 15 mm, because due to the presence of the locus of B in the top view here. With A as center, take the radius of A B1 and draw an arc such that it will going to cut the locus of B in the top view. So you are going to get this point B and join A to B with a dark line. When we join B and B dash, both will going to lie on the same line. So theta will be the true inclination with respect to HP, and phi will be the true inclination with respect to VP, and alpha is the apparent inclination with respect to HP, and beta is the apparent inclination with respect to VP. So this is how we will be able to solve the problem in orthographic view in sketchbook. Now we will going to take up how it is being solved by in stepwise. Now first we are considering the top view. Make the top view line parallel. A is in front of VP by 15 mm, and make B1 also in front of VP by 15 mm. So then it will going to be parallel to VP. So then you draw a vertical projector in the front view, and with A dash as center, cut an arc which is of the true length, which is going to be 80 mm. So you will going to get the locus of B in the front view. So this point will going to be B1 dash, and this will be capital B because we have this line parallel. So now this will be A dash and this will be capital A. So that is what we have shown here. So with AB, which is in space, when you rotate it and make it parallel, you will going to get this point which will be parallel to VP. So we will going to get the true length in VP. So now we will go for the front view. Now we have found out the true length in the front view. So this will going to be the locus of B. Here we will not going to get the locus of B in the beginning. So we will go to the next point. So here, when you make the front view line parallel, once we have got the locus of B, which is already there, so you make the front view by with A dash as center, cut an arc on this, you will going to get B dash here, join A dash B dash with this 50 mm. You make that line parallel. So when you make that line parallel, you are going to get A dash B2 dash, which is A dash is on HP, so B2 dash is also on HP, and draw a vertical projector into the top view. So with A as center, take the radius of 80 and cut an arc. You will going to get this point, which will going to be B2. Then join these two, which will going to be the true length. So this is the inclination phi, and draw the locus line. But you are already measured top view distance here. So you draw this, and then you are going to get the top view here on this point. So this is how which we have been done. So when you are rotating like this, that means in space we are rotated from A to B like this, so that it will going to come on the locus of B. So that is the path traced by this will going to be A dash B2 dash, because B is above HP, you make that B2 on HP. So you got that the line is parallel to HP, so we are getting the true length in HP. So AB2 is the line which is going to be the true length in VP. So the inclination made by the true length with respect to VP will going to be phi. This is how we will be able to solve the problem in the step by steps, which is also there. But actually this is the one which we need to show the final explanation. So we have removed some of the basic to find out the true length in HP. We have removed the front view, and we are to find out the true length in VP, we have considered from the top view. That is what we have shown in this and also in this.